Have you ever looked up at the night sky and wondered how it all began? For decades, we thought we had the answer. The Big Bang. A single, infinitesimally small, infinitely hot, and dense point that exploded, creating everything we see today. It's a powerful, elegant story that has dominated cosmology for nearly a century. But what if I told you that story might be wrong, or at least incomplete? Recent discoveries, especially from the James Webb Space Telescope, are forcing scientists to rethink everything they thought they knew about the universe's dawn. This isn't just a small tweak to the theory. This is a potential paradigm shift that could rewrite the first chapter of our cosmic history. Let's start with the classic Big Bang model. It's been incredibly successful. It predicts the expansion of the universe, the existence of the cosmic microwave background radiation, that faint afterglow of creation, and the abundance of light elements like hydrogen and helium. It's the bedrock of modern cosmology. The theory paints a picture of a universe that started about 13.8 billion years ago. In the first fractions of a second, it underwent a rapid expansion called inflation, smoothing out the cosmos. Then, as it cooled, particles formed. Then atoms, and eventually, gravity pulled matter together to form the first stars and galaxies. For a long time, the evidence seemed to fit this timeline perfectly, but science is all about testing theories, and the James Webb Space Telescope, or JWST, is the ultimate testing tool. It's like a cosmic time machine, peering back to the very earliest moments of the universe. And what it's seeing is unexpected. The problem lies with the very first galaxies. According to the standard Big Bang model, the first galaxies should have been small, clumpy, and a bit chaotic. It takes time for gravity to gather enough gas and dust to form massive, well-structured galaxies like our own Milky Way. We expected to see baby galaxies in the early universe, just starting to get their act together. Instead, JWST is finding galaxies that are shockingly massive and surprisingly mature, appearing just a few 100 million years after the Big Bang. These aren't cosmic toddlers. They look more like cosmic teenagers. They're far bigger and more developed than our models predicted could exist so early on. Imagine finding a fully grown oak tree in a garden where you only planted a seed yesterday. That's the scale of the surprise here. These ancient, massive galaxies are so common that they've been nicknamed universe breakers because they challenge the very foundations of our understanding of galaxy formation. So, how is this possible? If the universe started from a single point, how did these colossal structures form so quickly? This is the billion-dollar question that has cosmologists scrambling. It is forcing them to go back to the drawing board and consider ideas that were once on the fringes of scientific thought. The data is telling us that something is missing from our story. The standard model of cosmology, known as lambda CDM, which includes dark energy and cold dark matter, might not be the whole picture. It's like trying to solve a puzzle with a few key pieces missing. The picture we're getting just doesn't quite line up. One of the most mind-bending possibilities is that the Big Bang wasn't the absolute beginning. What if it was more of a big bounce? This is an idea from a theory called loop quantum gravity. In this scenario, our universe did unemerge from a singularity, the point of infinite density, where the laws of physics break down. Instead, it could be the result of a previous universe that collapsed in on itself, reached a point of maximum density, and then bounced back out, creating the universe we know. It's a cyclical process of expansion and contraction. If this is true, our universe could have inherited structures from a previous cosmic era, which could explain why those early galaxies were already so developed. It wasn't their first rodeo. Another fascinating idea gaining traction is that the universe might be much older than we think. The current estimate of 13.8 billion years is based on the rate of cosmic expansion. But what if that rate wasn't always constant? Some physicists, like Rajendra Gupta at the University of Ottawa, have proposed a tired light hybrid model. The idea of tired light, where light loses energy as it travels through space, is an old one that was largely discarded. But Gupta combines it with an evolving understanding of physical constants. In this model, the universe could be as old as 26.7 billion years. That's almost double the current estimate. An older universe would provide plenty more time for those massive early galaxies to form naturally, without breaking any rules. Then there's the mystery of dark matter. The standard model assumes that dark matter is cold, meaning it moves slowly. This allows it to clump together easily and form the seeds of galaxies. But what if dark matter isn't so cold after all? Maybe it's warm or has more complex properties. Or, perhaps, dark energy, the force driving the accelerated expansion of the universe, behaved differently in the early cosmos. Some theories suggest a period of early dark energy that gave the universe an extra push, which could have accelerated the formation of structures. These are not just wild guesses. They are serious theoretical proposals being developed and tested against the new data from JADA. Important to remember that this is how science works. It's not about having all the answers. It's a process of discovery, of questioning, and of constant refinement. The Big Bang Theory isn't being thrown out the window just yet. It's being stretched, challenged, and possibly expanded. We might be on the verge of discovering a new, more complete theory of cosmology, one that incorporates the Big Bang but adds new, crucial chapters to the beginning of the story. The JWST's observations are not a failure of the old model, but a triumph of the scientific method. They are pushing us into a new era of understanding. Think of it like this. For a long time, we thought the Earth was the center of the universe. Then Copernicus and Galileo came along and showed us we were just one planet orbiting the sun. It was a huge shift in perspective. Then Hubble showed us that our galaxy is just one of billions. Each step revealed a grander, more complex cosmos than we ever imagined. We might be at another one of those moments right now. The universe might be older, bigger, or stranger than our theories currently allow. So, what does this mean for us here on our tiny blue dot? It means that we live in an incredibly exciting time for discovery. The questions we re-asking now are some of the most fundamental ones we can ask. Where did everything come from? What happened at the very beginning? We don't have the final answers yet, but for the first time in history, we have the tools to genuinely search for them. The next few years of data from JWST and other telescopes will be crucial. They will either help us patch up the existing Big Bang model or lead us to a completely new and revolutionary understanding of our cosmic origin. The story of the universe is still being written, and we get to watch it unfold in real time. The next time you look up at the stars, remember that what we thought was the first page of the story might actually be the middle of a much longer, more incredible book. And we're just now starting to read the chapters that came before. Thanks for watching. If you found this cosmic journey as fascinating as I do, don't forget to like, subscribe, and hit that notification bell for more explorations into the biggest questions in science.